From controlling your gaming frame rates to controlling the future of artificial intelligence, Nvidia went from a struggling startup to a $3 trillion monopoly that makes Apple look humble. Right now, if you want to build serious AI, you have exactly one choice: buy Nvidia chips. OpenAI needs them, Google needs them, Meta needs them. Even China is desperately trying to smuggle them. Nvidia knows it. They've jacked up prices to $40,000 per chip, created artificial scarcity, and forced customers to buy entire ecosystems just to get access. Jensen Huang personally decides who gets chips and who doesn't, like some kind of tech mob boss. And the wildest part, this empire was built on accident. Nvidia just wanted to make video games look better, but first we need to rewind to 1993 and a Denny's restaurant in San Jose. In 1993, three engineers walked into a Denny's restaurant in San Jose, California, and decided to start a company. Jensen Huang, Chris Malachowski, and Curtis Priam had a simple dream: make graphics cards that could render 3D video games better than anything else on the market. And this was the era of Doom and Quake, where gamers were obsessed with getting smoother frame rates and more realistic explosions. Pretty humble beginnings for what would become a $3 trillion empire. But here's the thing, Nvidia almost didn't make it. The company nearly went bankrupt multiple times in the late 1990s. They were burning through cash, competing against giants like 3DFX and ATI, and struggling to get their products into computers. Total bloodbath. But in 1999, everything changed when Nvidia released the GeForce 256. The first chip they marketed as a true GPU, a graphics processing unit. And this wasn't just marketing hype. The GeForce 256 was genuinely different. While traditional CPUs handled tasks sequentially, one calculation after another, the GPU could handle thousands of simple calculations simultaneously. Parallel processing, gamers loved it because it meant butter smooth frame rates and graphics that actually looked good. Your copy of Half-Life suddenly looked incredible. But here's where it gets interesting. While gamers were using these chips to shoot aliens and race cars, a handful of computer science researchers noticed something else. These GPUs weren't just good at rendering explosions, they were insanely good at a specific type of math: matrix operations and linear algebra. Well, it's the exact kind of math you need for neural networks and machine learning. Wait, what? Nobody at Nvidia was thinking about artificial intelligence in 1999. They were thinking about Lara Croft's polygon count. But the architecture they'd built for gaming, thousands of cores doing simple math in parallel, turned out to be accidentally perfect for training AI models. It's like building a truck to haul furniture and then discovering it's also the best vehicle for racing. Pure dumb luck. But Nvidia didn't stay lucky by accident. By the mid-2000s, researchers at universities and tech labs were discovering something wild. GPUs, these chips designed to make video games look pretty, were absolutely destroying CPUs when it came to training neural networks. The reason was simple math. Training an AI model requires performing millions of matrix multiplications, the same operations GPUs were built to handle for rendering graphics. Perfect match that nobody planned. But here's where Nvidia separated itself from every other hardware company. In 2006, they released CUDA, Compute Unified Device Architecture. This was a software platform that let researchers program Nvidia GPUs for anything they wanted: physics simulations, financial modeling, neural networks. Their competitors thought this was a waste of time. AMD and Intel looked at CUDA and basically said, why spend resources on niche academic stuff? Classic mistake, because in 2012, everything changed. A research team led by Alex Krzyzewski used Nvidia GPUs to train AlexNet for the ImageNet competition. AlexNet didn't just win, it crushed the competition, cutting the error rate in half. The AI research community lost its mind. This was proof that deep learning actually worked, and it worked because of Nvidia's hardware. Suddenly, every AI lab on Earth wanted Nvidia GPUs. Google, Facebook, OpenAI, universities, research institutes, they all started buying these chips by the thousands. Nvidia went from gaming company with a side project to the backbone of the entire AI revolution. By 2016, if you were doing serious machine learning research, you were doing it on Nvidia hardware. No alternative. And while their competitors were still focused on gaming margins and CPU dominance, Nvidia doubled down. They started designing chips specifically optimized for AI workloads. They built out the CUDA ecosystem with more tools, more libraries, more support. They didn't just sell hardware, they built an entire platform that researchers became dependent on. The lock-in was forming, but nobody understood how complete it would become until ChatGPT launched. November 2020 changed everything. OpenAI launched ChatGPT to the public, and within 2 months it hit 100 million users, making it the fastest growing app in history. People were having conversations with AI, getting it to write essays, solve problems, and answer questions that seemed impossible just months before. The entire tech world lost its collective mind. What does a viral chatbot have to do with Nvidia? Everything. Because the moment ChatGPT went mainstream, every major tech company on Earth realized they were about to get left behind if they didn't build competing AI systems immediately. Google panicked and rushed out Bard. Microsoft invested $10 billion into OpenAI. Meta pivoted hard into AI research. Amazon, Apple, startups, research labs, everyone scrambled to build their own large language models. But there was one massive problem. Training these AI models requires absurd amounts of computing power. We're not talking about a few servers in a closet. Building a model like GPT-4 or Google's Gemini requires data centers packed with tens of thousands of GPUs running 24/7 for months. Each major training run needs somewhere between 10,000 and 30,000 high-end GPUs minimum, and there's only one company making GPUs powerful enough to handle it. You guessed it, Nvidia. In 2022, Nvidia had just released their H100 chip, specifically designed for AI training workloads. This thing was a beast, massively more powerful than previous generations, optimized for the exact type of calculations large language models need. And the price tag, between $25,000 and $40,000 per chip, depending on configuration and who you knew. Suddenly, demand for H100s went from pretty good to absolutely insane overnight. Tech companies were placing orders for thousands of chips at a time. Waiting lists stretched to 6 months, then 9 months, then a full year. Jensen Huang, Nvidia's CEO, realized he was sitting on infinite demand for a product only his company could make. Pretty good timing, right? Or maybe the luckiest business position in modern history. So Nvidia had every tech company on Earth desperate for chips they couldn't produce fast enough. What did they do with that power? Exactly what you'd expect from someone holding a monopoly. They allocated chips to the highest bidders first. If you were a tiny startup trying to build the next breakthrough AI model, good luck. You were at the back of the line behind Microsoft, Google, and Meta, who were buying tens of thousands of chips at a time. Jensen Huang personally approved the largest orders, treating customers less like clients and more like supplicants begging for access. But it gets better. Nvidia started bundling requirements. Want those H100s you desperately need? Great. But you also have to buy our networking equipment and our software subscriptions, and maybe consider using our cloud services while you're at it. It's like buying concert tickets from a scalper who says, sure, I'll sell you the tickets, but you also have to buy my t-shirt and my parking pass and a beer. Except instead of a concert, it's the future of your entire company. And here's the kicker. Nvidia could have ramped up production to meet demand faster. They chose not to. Artificial scarcity keeps prices high and customers desperate. Why flood the market when you can maintain year-long waiting lists and charge whatever you want? The result? Nvidia's profit margins hit over 70%, which is absolutely insane for a hardware company. For context, most hardware manufacturers are happy with 20-30% margins, but when you control 95% of the market and every customer needs your product to survive, you can charge basically whatever you want. Tech companies had zero choice. Pay up or get left behind in the AI race while your competitors sprint ahead. It's not like they could go to AMD or Intel for equivalent chips. AMD's best AI offerings were at least 2 years behind. Intel's ambitious Ponte Vecchio chips flopped hard when they finally launched in 2023. Thanks for nothing, competition. But that's not even the worst part, because Nvidia's real monopoly isn't just about making the best chips. It's about the software ecosystem they built over 15 years that makes switching to a competitor basically impossible. Remember CUDA from 2006, that software platform Nvidia released when everyone thought they were wasting time? That's the real prison, because for over 15 years, AI researchers, data scientists, and developers have been writing code exclusively for Nvidia hardware. Millions of lines of code, entire careers built on CUDA expertise. Every major machine learning framework, PyTorch, TensorFlow, JAX, is optimized primarily for Nvidia GPUs. Imagine if you spent 10 years learning to drive a Toyota, and every road, every parking lot, every traffic system was designed specifically for Toyotas. Then someone offers you a Honda that's 80% as good but cheaper. Sounds great, right? Except now you have to relearn how to drive, and none of the roads work quite right, and you need to rebuild your garage. You're probably just going to stick with the Toyota. That's the CUDA lock-in. Even if a competitor made a chip that was 80% as good as Nvidia's at half the price, companies would still need to rewrite 100% of their code base to use it. That's months of engineering time, countless bugs, and the risk that it won't work as well. Nobody wants to do that when they're racing to build the next AI breakthrough. The network effects make it even worse. Like more developers use Nvidia, which means more tools get built for Nvidia, which means more tutorials assume you're using Nvidia, which means more developers learn on Nvidia, which means more companies hire people who know Nvidia. Self-reinforcing cycle that competitors can't break into, right? Every computer science program teaches CUDA. Every online course defaults to Nvidia. Every Stack Overflow answer assumes you're working with their hardware. Of course, they thought of that. Diabolically smart. Even if AMD or Intel magically released a better chip tomorrow at half the price, the switching cost is so monumentally high that most companies wouldn't bother. Surely someone could challenge Nvidia, right? With this much money on the table, competitors must be making progress. So let's take a tour of the graveyard. AMD released their MI300 series chips in 2023 and 2024, marketing them as serious Nvidia alternatives. On paper, the hardware specs looked competitive. Some benchmarks even showed performance close to Nvidia's offerings, but nobody cared. The CUDA lock-in was too strong. AMD's market share in AI training chips sits around 5%. Nice try. Intel had even bigger ambitions with their Ponte Vecchio data center GPUs. They delayed the launch multiple times, burning through billions. When the chips finally arrived in 2022 and 2023, they were underwhelming, plagued with software issues, and arrived too late to matter. Intel's AI chip division has been a spectacular failure. What about Google? They've been making their own custom chips called TPUs, Tensor Processing Units, since 2016. These are legitimately powerful and optimized specifically for AI workloads. But here's the catch. Google only uses them internally. They don't sell TPUs to other companies, which means they can't build an external ecosystem. Strategic mistake. Then there are the startups. Companies like Cerebra's, GraphCore, and Samba Nova raise billions with promises to dethrone Nvidia. They build innovative chip designs, wafer-scale processors, specialized architectures, and they've collectively captured maybe 1-2% of the market. Turns out, building good hardware is the easy part. Building an ecosystem that developers actually want to use, that's the impossible part. China deserves special mention. In 2022, the US government banned Nvidia from selling their most advanced chips to Chinese companies. So Chinese tech giants and the government poured resources into developing domestic alternatives. Companies like Huawei and Alibaba are working on their own AI chips, but they're still years behind Nvidia's current technology. Even Apple, with effectively infinite money and some of the best chip designers on Earth, uses Nvidia GPUs for their AI research. Current market share, Nvidia controls over 95%. Everyone else is fighting over scraps. So Nvidia has a monopoly, competitors have failed, and Jensen Huang is probably the most powerful person in tech right now. But here's why you should actually care about this, even if you're not building AI models. First, Nvidia's monopoly controls the speed of AI development globally. Every breakthrough, every new model, every advancement has to wait in line for Nvidia's production schedule. One company's production decisions are literally gating how fast humanity develops artificial intelligence. Second, this creates a massive barrier to entry for startups and smaller companies. Want to build a competing AI company to challenge OpenAI or Google? Great, but you'll need at least $10 million just to buy enough GPUs to train a decent model. Probably more like $50, $100 million for anything serious. The only players who can afford to compete are giant tech companies that already have billions in cash. Microsoft, Google, Meta, Amazon, they're the only ones who can play this game. Third, prices never go down. When you control 95% of a market, there's zero incentive to lower prices. Nvidia can charge whatever they want, and companies will pay it because they have no choice. GPU prices have stayed high or increased even as production costs have come down. Fourth, innovation is bottlenecked. Researchers with brilliant ideas can't test them because they can't get access to enough computing power. Academic labs that used to lead AI research are now priced out of the cutting edge. And here's the part that hits consumers directly. Remember that $20 per month you're paying for ChatGPT Plus? Part of that cost is because OpenAI is paying Nvidia billions for GPUs. Every AI tool you use, every subscription, every service, they all have Nvidia's monopoly pricing baked into their costs. The bigger picture. Whoever controls the infrastructure for AI development controls AI itself. And right now, that's one company run by one CEO who personally approves major chip allocations like some kind of tech kingmaker. Here's the thing about Nvidia's monopoly. They earned a lot of it. They made smart bets when competitors didn't. They invested in CUDA when everyone said it was pointless. They pivoted to AI before anyone else saw the opportunity. Jensen Huang built this empire through vision and ruthless competence. But monopolies are never healthy long term, even when they're earned. They stifle innovation, extract maximum rent from customers, and create dangerous single points of failure. Should one company control the infrastructure for the most important technology of the century? That's a legitimate question. Nobody in power seems to be asking seriously. No meaningful antitrust investigation, no regulatory pressure. Nothing. Will it last forever? Probably not. There are potential threats on the horizon. New computing paradigms like quantum computing could eventually disrupt the GPU monopoly, though that's still years or decades away. Chinese competitors might catch up if they pour enough resources into it. Cloud providers like Amazon, Google, and Microsoft are investing in developing their own custom AI chips to reduce dependence on Nvidia, but those efforts are in early stages. Jensen Huang knows this won't last forever. He's smart enough to recognize that every tech monopoly eventually faces disruption. So he's milking it while he can, maximizing profit margins, and building a war chest for whatever comes next. But for the next 3 to 5 years, Nvidia is the AI industry's landlord. Every company building AI pays rent to them. Every breakthrough waits for their approval. Every innovation is gated by their production capacity. Maybe that's fine. Maybe having one dominant player accelerates progress by creating a stable platform everyone can build on. Or maybe we're watching the formation of a tech oligarchy that makes the oil barons of the early 1900s look quaint. A handful of companies controlling the infrastructure of intelligence itself. How's that stock portfolio looking, by the way? But there you have it, how Nvidia went from making graphics cards for gamers to becoming a $3 trillion monopoly that controls the future of AI. Click this video right here because this one's over.